Okay, today we're looking into the basics of probability. And let's start from what is probability. Can you tell me
What are the odds of getting hens?
what is probability?
What's that?
The chance something happens.
I didn't even get one.
Okay,
The likelihood of outcomes.
probability is number
Over time, it's tried.
of
Outcomes.
favorable outcomes
Over outcomes.
Yeah, Mr. Mayor, I didn't get one.
outcomes over the total number of outcomes. So, if you roll, for example, normal six-sided die, what the probability of get
One
five,
One
get
over
five,
7, 10%.
you're answering without even listening to question. What if I will ask what the probability of get even number?
Half.
3 over 6.
Three.
Half.
Favorable out of six,
Thank you.
so
I would say that's half of a percentage.
so it will be half. Now, probability can be expressed as a fraction, decimal, or percentage. What is the smallest the probability can be?
0.
0. That means something not gonna happen. What the probability roll normal six-sided die?
1.
What the probability of get 7?
1.
0.
0. It cannot happen. What the probability maximum
1.
is 1. That means it definitely happens. So if you roll a die, what the probability of get number from 1 to 6?
100.
That will be 1 or 100%. Well, there are, if we have something that we call event A, let's say tossing, rolling a die and get 5 on the die, and that's event A. Then A dash, or
Derivative.
complement A, that means not A.
5 and 6.
That will be everything but 5. That complement. Complement means not A. Hmm?
That's a good compliment.
So, now,
I like his edge.
there are
No, you can't
different,
be saying
different ways to present probabilities. One of the ways to present probabilities is when we have, let's say, multiple events, is a tree diagram. And for example, we toss
Oh, that's the worst.
coin
Oh, it's so fun.
3 times. If you toss
Is
a
everything.
coin 3 times, what is the outcome when you toss first coin? What outcomes we can get?
H or T?
Head or tail?
Oh, I thought we were doing out of
When
three.
we toss coin second time, head, tail, head,
So this is the
tail. We toss
Great.
coin third time, head, tail, head, tail, head, tail, head, tail. So now we can list all possible outcomes. Here we have head, 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 tail, head, tail, head, head, tail, tail,
Very just the truth there.
tail, head, tail,
The triple black
Yeah,
black
tail.
right?
tail, tail, head, tail, tail. How many possible outcomes we have?
Oh,
Eight.
One
We
in
have 8 possible outcomes. So what will be
12.5%.
probability of get 3 heads?
12.5%.
What are the,
One over 8.
As a fraction,
One over 8.
what are the chances of that?
One.
Cancel that.
So,
it's 1 favorable outcome out of all 8. What the probability of get, let's say, 2 tails? What the probability of get two tails?
About half.
No.
3
Four,
8.
yeah.
Exactly two tails.
Quarter.
2 over 8. 1.
We have two tails. 1,
3
2, 3.
Uh,
So 3 out of 8.
That was a trick question.
That's a question for year 8.
Uh,
Now, that's one of the ways is use tree diagram. Another way to present probabilities is two-way tables. Because, for example, if you try to represent outcomes, if you roll 2 dice, you'll have like on the first 6 and then 6 for each, it will be too messy. So in such case, it's much more convenient to do it in this way. What we can get on the first die? 1, 2, 3, 4, 5, 6. And if you're looking for sum of the numbers,
36.
of the uppermost numbers,
6 times 6 is
we'll have
76.
2, 3, 4, 5, 6, 7,
2 4.
3, 4, 5, 7, 8. If you add numbers, we have 4, 5, 6, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So what will be the probability? How many outcomes we have?
36.
36. So what will be the probability to get number that is greater than 8? How many outcomes we have?
10 on 36.
We have
Seven.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36, and everything that can be simplified must be simplified. 5 on 18. So this is called two-way table, and it's useful to use when we have multiple outcomes. One more way, what is another visual way that you've learned before to represent probabilities?
Venn diagram.
Definitely.
Yes. Well done. Yeah,
Stem and leaf is for statistics,
Not
not
either.
for probability.
Big ups, boys.
So let's say there is a class, let's say there is a class of 25 students. And 15 doing some sport,
Yeah.
and 8 doing some music, and 2 students both. How we can represent it using Venn diagram?
A sports circle and a music circle.
Sport, music.
Wow. Very small box.
So we
Quite
put
big.
here 2. How many will put here?
13.
13.
13.
Because those will be who doing sport but not doing music. What
6.
we'll have here?
6.
6. And what will be
4.
0.
Wait. No.
4.
15
Needs 2.
plus 10,
Yeah.
no 15
Yeah.
plus 6, 21. So we have 4 that not doing music, not doing sport. Make sense?
Yeah.
Now, what is here? We call it intersection. S intersection M means and. So students here, they doing both sport and music. And here, all of these
Use that as strawberry.
all of this called union, means all. S, union M, that means all. Students doing addition rule. We have the probability of S union M will be equal probability S plus probability M. Will they be equal?
No.
Minus.
Minus
Probability.
intersection, yes. Minus probability of intersection. So that is addition rule for probability.
Times 2, no?
No.
Minus
Because
15.
you know minus is from
Just trying to get him.
Now,
No, I mean
there are
serious.
two
You have to
types.
find minus
two-
from both.
There are two types.
You have
So
to
the
minus,
minus it's only once.
you have to minus it from the sport group and the music.
No, that's
So we exclude them at all. We're not counting them at all.
Oh.
If you subtract twice, we will not count them at all. We just need to count them once, not twice.
Gotcha.
Now, there are, if event S, what we can say about the probability of not S. What it will be probability complement S, what it will be equal in terms of probability.
6
10
on
over
25.
25.
I mean, it will be 1 minus probability S. The probability of event and its complement, they must add up to 1. Now,
So, 24.
mutually exclusive event.
Ooh, that's cool.
Mutually exclusive events will be, when you roll a die, will be getting a 3 and even number, will they be mutually exclusive?
Yes.
Yeah, if you get 3, you don't get even number. If you get even number, you don't get 3. They are mutually exclusive. You cannot get both at the same time. Will be probability of get 5 on the die and probability get number greater than 3. Will they be mutually exclusive?
No.
No, because you can get 5 and it's 5 and it's greater than 3. So for mutually exclusive events, Venn diagram looks like this. They don't intersect. Mutually exclusive. One happen, another not. And another type of event is independent events. If we have event A and B, A and B are independent if probability A intersection B equal probability A times probability B. First question, so returning to this example, what the probability of S? Probability of S
Well,
3
15 on 25.
is 15 out of 25, which simplifies to 3/5. Probability M
8 on 25.
is 8 on 25. What the probability of the intersection?
2 on 25.
We have 2 in the intersection on 25. Now, let's multiply these two. 3/5 times 8 on 25 equal 24 on 125. And it's obviously not simplifies to this. So I went S and M independent. No. If this node does not hold,
Oh, okay.
they are not independent.
Right.
Now, can events be at the same time mutually exclusive and independent?
Yeah.
Yeah.
No. If they are mutually exclusive, what the probability of the intersection? 0. And if they are not zeros, any of them not zero, it doesn't hold. So if events are mutually exclusive, they are not independent. And if events are independent, they cannot be mutually exclusive. That is pretty much just remind you about the probability, what you're supposed to know about probability by now, and we'll continue to learn about probability tomorrow.
Thanks today.
See you guys.
Just.
Like, what-